everybody. This is the Alex Manassa, and today we're going to take the guitar amplifier and we're going to go and lay it out. So behind the scenes, I have done a little bit of work. Let me show you what I got here. I've put in a linear regulator, the 7805. It's tried and true. This should be our nice low noise voltage regulator to go from our 12 volt rail, which is the input to the circuit board. So what I'm going to get out of the wall is 120 volts. It's going to go through a wall wart adapter, a 12 volt, 2 amp power supply. That's going to come into this board via a terminal block here, and that's going to come through the 5 volt and provide my digital logic power. Right now, that 12 volt is going to go into this dual rail voltage supply right here, the ADP 5071. This is a TSOP package with a thermal tab. And the thermal tab, I believe, is P ground. No, wait a second. It would be... I forget which of these is the thermal tab. Because I have two different grounds on here, I've got a signal ground as well as a power ground, right? The signal ground is going to be for all the digital stuff. It's going to have a lot of ringing, digital signal noise. Like when you have a signal level go straight, like go from 0 straight up to 5, it's not really a straight line. What it does is it ends up ringing, right? If you take a Fourier analysis of a step function, right? Your step function is a 0, and then it goes up to some number, say 5 volts, right? If you do a Fourier analysis of that, you're going to get the actual noise components, the frequency components of that digital signal, and you're going to find that there's a ton of noise associated with that, and that's going to ring throughout your entire circuit, right? So you're going to want to, and that ringing is going to return through the signal ground, right? So that's labeled as GND here. You don't want all that ringing on the same ground that you're going to be doing all of this analog stuff, right? In this case, it's going to be audio amplification, right? So we've got a ground that we're going to keep to our signal here, and you can see I haven't really corrected all that just yet. Like this should really be my analog ground, this ground ref, what's called ground ref, right? Let me just check and make sure. The only thing that should have a digital ground is a digital signal. Right, so you'll see that the mute has a bypass to the signal ground, right? So the mute button and all that, those are mute and standby here. Those are powered through a 5 volt. I wonder if I should. I mean, they are still on the same circuit though, so I wonder if I should go ahead and take those and put them elsewhere. I think I am. I think I'm going to go ahead and change those since I don't see a 5 volt rail going into the TDA 7293. There's no actual digital ground that's separate from the analog amplifier ground. So what I'm going to do is I'm going to take these guys out and move them here. Okay. There we go. Just change my ground reference. Very good, very good. Just do a little check, make sure everything else is good. Make sure everything else is good. VREF goes to, according to the data sheet, let me zip in there and grab that. That's my taser, sorry about that. Music amplifier, which is actually audio amplifier. I didn't really choose I didn't settle on a name. I decided to go audio because it's not necessarily going to be for music. All right, there we go. So you'll see on the circuit diagram for the ADP 5071, and that's the correct ADP 5071, you're going to see that there's two different grounds. There's this sort of 3-barred ground. All right, kind of looks like an upside-down Christmas tree. And then you got just a triangle ground, right? That's going to be your digital signal ground. This VREF is bypassed to the signal ground, okay? So I'm just holding with that convention. The only things that have the audio ground are the VIN, the V positive and V negative rails, and the switch 2. And that appears to be it. So let's check that. So VIN, positive negative rails, and switch 2. So VIN, okay, positive negative rails right here, okay, and then switch 2. So switch this FB1 actually has the signal ground on it. I'll be darned. Okay, so I'm going to go ahead and just put that on there. Okay, and I got to move that because that's ugly. That is so ugly. Field value, yep, all right. Okay, how about pin 1, P ground? What does that get? Okay, yep, P ground is going to the signal ground, right? That's what I'm bypassing to. Okay, VN, Good. Okay. VN is getting the signal ground. Very good. Very good. And switch 2 here. All right. So that looks good. That looks great. Now I'm just doing the data sheet decisions. I'm just doing what the data sheet's telling me to. Far be it from me to second guess it. However, once I do put the circuit in, I have a couple of test points that I've decided to put on the positive VSW and the negative VSW power planes, so I can monitor the quality of that power supply with my oscilloscope. That's going to allow me to do quite a bit to ensure it's good. Now, what I didn't realize is that I'm probably going to need to step that down, because 40 volts, it's going to be a lot. And I'm going for the positive minus 40 volts, right? That might be a bit much for my oscilloscope to handle, so I got to check the voltage ratings. I think one of my oscilloscopes should be able to handle it. I've got a Rigol, and I also have an analog discovery too. Okay, and of course you have my signal. I've got my signal ground and my digital ground. Those are joined together via a jumper, right? It's going to be a 0 ohm resistor, which is just a jumper. That way, I have a controlled area where I can join the two. And I haven't decided if I want to join it at the dual power supply, the dual rail power supply, or if I want to join it at the audio amplifier. So I've given myself an option. I'm going to physically place R15 near the amplifier, or sorry, near the dual rail power supply. And then R16 is going to be near the audio amplifier. Okay? Oh, I forgot to put my ground here. It's a fatal mistake. Boom. All right, done. Cool. Very cool. And the ground for the audio amp is going to be all of this audio ground, all of it. So there's no more signal ground even touching it. Very good. Okay. All right, feel good about that. Probably tells me that I'm going to need to join these two grounds together towards the dual rail power supply, since there's no digital ground that I want to propagate towards the audio amplifier. But, you know, I like to give myself options. We'll see. All right, so I've given everything a footprint. I feel pretty good about everything. All right, if I go to my audio amp build materials, my 1 microfarad is an 0603. My 0.047 microfarad, which is a 47 nanofarad. Here's the 47 nanofarad. That is also an 0603. Okay, 0603. 0603. Now, if I make a mistake, it's pretty easy to change this, and I'm going to go over this tomorrow. I figured I'm going to go ahead and do this tonight. I might as well get it on camera. Why not? Now, the 10 microfarads, I believe I gave a 1206. That's right. And I think I've got a good number of 10 microfarads on this circuit. At least 6. Now, of course, I generated a bill of materials. All right, so I can go ahead and just generate that. I'm using the BOM HTML group by value. That allows me to more easily... Where is KiCad? Okay, well, I can't find KiCad, so I'm going to just go down here to get it. All right. So this was generated earlier today, so this is not the one I want. So let's go to Music Amp, Audio Amp. Get rid of that one. .html. I don't know why they make it so hard for you to do it. Doesn't seem necessary. So that's my taser. That's for the taser. So there are 10 of these. Okay. So this is the bill of materials I've just generated. So I've got 1 millifarad, which is 1,000 microfarads. It's the big caps, right? I've got 100 nanofarads. I got 2 of those. I got 10 microfarads. 3 1 microfarads. Okay. Everything looks pretty good. You know, I think I forgot to purchase. Did I forget to purchase 680? Oh, crikey. I have to go check my DigiKey order and make sure I ordered the right stuff. Whatever. It's all right. I'll go fix that later. DigiKey's pretty cool about adding stuff on if you get them, you know, soon enough. I don't like to do that, but it's a law that you always forget something if you order something from DigiKey. You're always going to forget something. That's okay. You got to live with it. All right. And if I get a footprint wrong, it's not the end of the world. Okay, let's go ahead and generate our net list. Just go ahead and put it right in our same directory. We're going to go and run PCB new. Now I'm interested to see what this is going to look like because I've got some big components on here, including the 1/4 inch. Oh, wow. All right, that was fast. Oh, cool. 0 warnings, 0 errors. You'll love to see it. Okay. Yeah, so I've got some big components, as you can see. The capacitors, anything that has anything to do with power is going to have big caps. Okay? So, as you can see, that's going to dominate, absolutely dominate the real estate on here. And I've not put a heatsink on this audio amplifier yet. I'll probably find like some piece of metal I could just put on there later because I don't know if I'm going to need it or not. So we're just going to see how that goes. All right. So as I always do, you got to group these things just as your schematic says to do, right? So you've made the schematic and it's going to be nice and pretty. Everything's grouped together properly. Same thing still holds for your PCB. So what you're going to do is you're just going to grab everything that has to do with that's grouped together here. You've logically grouped everything together on your schematic. So now it's time to go ahead and do that in the physical realm. All right. So I'm going to move this. Okay. I'm just going to grab my major components. There's the dual rail power supply. Here is the linear power supply or voltage converter. Okay. I've got my terminal block. I'm going to move that there. Okay. That's dual rail power supply here. These big caps are called for near the amplifier, so I'm going to move them where I'm going to put the amplifier. And I'm just sort of rotating them for no reason. There's no reason for me to rotate them. I'm just being nervous and weird. All right, put these two switches near each other. All right, all right. Things are happening. Okay, I've got an inductor that's going to go with the dual rail power supply. Okay. This doesn't have to look pretty. Not yet. All right, here's the audio in. Let's put that up here. Yeah, let's put that up here. I'll take the 12 volts input and the 5 volt output. I'm going to put that there. Okay, so here's the audio amplifier. That's going to be a big boy. I'm going to put the heat sink so it's kind of facing away from everything, right? So this right here is where the heat sink's going to go eventually. So I'm just going to go ahead and move that away. All right, another inductor that goes to the dual rail. I'm just clustering these together. There's no rhyme or reason for why I'm doing that. Oh wow, what'd I do? Just come on. There we go. Oh, it's gonna get pretty tough with all these capacitors. I'm gonna have to be alt-tabbing like crazy. All right, the diodes are flyback diodes. Those go near the power supply. I don't even know where this goes. Okay, I'm just gonna take a lot of these capacitors and just move them away. Like here's a lot of 10 micro capacitors. 12K. These weird values for resistors are gonna go with the dual rail. All right, so I got a 47. Don't want to do that. Okay, that's the speaker. That's going to be the output. I'm just going to put that over here. All right, 10K. That looks like it goes with the switch. So I'm just going to put that near the switch. It looks like I'm correct. The 0 ohm jumpers, pretty sure those go with the... Yeah, those go with the power supply. So I'm going to put... that's R4. So let's check it. All right, the alt-tabbing begins. R4 goes with switch 1. So which one of these guys is switch 1? All right, switch 1 is this guy. Okay. That makes some sense. All right. 1 microfarad C18. Where do you go? All right, so C18 goes with the dual rail power supply. 5M11, that's 5 mega ohm, 5 5 mega ohms and 110 kilo ohms, so 5.11 mega. I don't know what one of my cats is doing. This is an R2. R2, that's 22. That must go, I think that goes to the amplifier. I'm going to put that over here. Okay. Moving right along. All right, C6. So I got a C5 and a C6. So 5 and 6 both go with the amp. So both you guys can go over here. I got C8 and C15 now. So where do you go? You also go with the, all right, so C8 goes with the amp. So does C9. Okay. Well, I don't see C9 in this cluster. Oh, there it is. Actually, never mind. It's right there. So you guys are going to go together. Very cool. C15, where do you go? All right, you are the output of the amplifier. So we're with the amplifier. And I'm going to put the outputs of the amplifier. I'm not even going to... You know what? I was going to put the outputs of the amplifier on the right and the inputs on the left, but that doesn't really buy me anything. That gets me nothing. All right, goes with switch 2. Here you go, switch 2. There you go. Here we've got 5M9. Yep, that goes with the... That goes with you. 470 nanofarad. That looks like it goes... Nope, actually that goes the input of the amplifier. I'll be darned. So here we go. That's going to be a good candidate of putting on the backside because I've got 2 through-hole components. So those are already going through the circuit board. So I can connect those to the back and the front at the same time. They're kind of a through-hole component is sort of a via along with being a component. So, all right, switch 1. But you go to the mute signal. So although it looks like, this is not the best logic I've ever used, but C10 looks like it's near the switch. I really want it to be near the chip. I really want it to be near the chip because that's what I want to filter the noise from. You know, it's better to filter at the receiving end than the sending end because you never know what you're going to pick up along the way. So I'm just going to put you there. How about that? Now, I wish I could disable certain nets. I would love to disable the grounds because you just don't need to see the grounds most of the time. All right, C11, you go with switch 2, but same deal, same deal. It's for the standby button, but I want that to be near the chip. All right, C11. Wow. Wait, that's supposed to go over here. What the heck? I didn't unclick it. All right, here's C17. That goes to the input of the amplifier. Slowly but surely, we're making sense of this. It's going to be very slowly. All right, R16, you are one of the ground jumpers, and I wanted to put you near the amplifier. Okay, very cool. We're going to have 2 different copper pores, I think, is what's going to happen. I'm going to have a signal copper pore that has all the digital stuff, and there's going to be a amplifier copper pore. Now, the reason why I'm not worried about mute and standby, their digital noise, because you're only going to press them once, so they're not really going to be digital signals that are switching constantly. They're only going to pop or have noise when you press them, right? And, you know, amplifiers have pop and noise when you press the mute and standby buttons. And that's just going to be true here. It's not a problem worth solving. Okay. C13. Okay, you're with the LM. Oh, all right. C2. C2, you're a filter, and you are for the, yep, okay, you're for the power, you're for the amplifier. All right, 680. Oh, okay. So 680 is actually for this right here. All right, so part of the feedback circuit. Alrighty, so I'm going to put you near the amplifier. And you go with C9 and 8. So all you guys are a unit. Y'all are friends. Okay, we got R15. That looks like the jumper that needs to go near the, near the dual rail power supply. And that's done. Okay, got R6. Goes with switch 2. My cats are over there just making a ton of noise. I don't know what they're like playing with something on the ground. I don't know. Cats do weird stuff. All right, C4 goes to the amplifier as well. Just going to put that vaguely nearby. So what I'm doing is I'm chunking these up and I'm going to ignore a lot of the strands that are going between the chunks. It's going to make things a lot easier and a lot more sane. And that way I can just ignore like all of these strands here that my mouse is going past, and all these strands here, I'd ignore them and just detangle the ones that are inside that group. I know it's not ideal. Ideally, I would only enable the nets that are within that sort of chunk. But unable to do that, I'm just going to have to just mentally filter that out. All right, it's not ideal, but it will work. It will work. All right. R8, you are a jumper resistor. Just in case I make a mistake with the enable line. Okay. All right, R12. Yep. Compensator number 2. Okay, 137 kilo ohms. Yep. I usually worry about the grounds last. The grounds are the easiest. They just go to the back plane. All right, you go with the 7805. Here's 5.6K. Compensator number 1. All right. All I got to do now is move the... Here, 1 second. 1 second. Hey. Get out of here. That was driving me nuts. That was driving me nuts. Imagine if someone was just sort of like rattling a screwdriver inside of a tin can. That's what those kittens were pretty much doing. Come on, get out of here. All right. Yeah, they were playing with the twist sticks. They like cornered it by my guitar amp. Oops, wrong one. All right, so that is, okay, test point for the power supply. Let's put that near the amplifier. Okay, so these test points are just little areas that I'm going to solder a piece of metal to so that I can check on signals. So I want to check on the quality of my power supplies. You know, if I'm using the amplifier and I'm seeing that when I'm really powering onto it, if I see like plus VSW or minus VSW start to sag, that tells me that I'm actually having a current draw issue, right? And that's bad. You don't want that. All right, raw signal is going to be over here. I don't know why I'm rotating it so much. There we go. I'm used to seeing the text go in every direction, but in here, KiCad is pretty smart. It lets you, it only has the text go in 2 different directions. All right, so this is power ground. Well, where do I want to put that? The ground I'm going to care about most is probably going to be near the amplifier, to be honest. Yeah, so I'm just going to put that on the other side of this amplifier. Okay, cool. Here's plus VSW again. I'm going to want that near the amplifier. That's where it's going to count. I want to see all the noise. I don't want to see it from the source. The source is going to drive it strong. I want to see the noise that gets added between the source. Oh man, this is a chunker. Chunky boy. Whew. Okay. I'm probably going to put it like real close. Like these caps are going to be super close. But I'm going to put them right there for the moment. I think I'm going to go ahead and flip almost all those surface mount components onto the back of this board. Yeah, I think that's going to have to happen. Just to fit this thing and keep it sane, right? Okay, and C14, you come here. Now, okay, so I want the out to be over on this side, around here, right? And the only thing I really have on the out is just a test point and then the connector for the speaker, right? Because I'm going to keep the speaker really simple. I'm just going to have it go to some headers. Plus 12 volts. I'm going to put the plus 12 volts. That's coming in, right? Yeah, so I'm just going to have that right there. How about that? Okay. Signal ground, signal ground, signal ground. Let's put you there. Yeah. Okay. 6.1. That's trip switch. I don't... Yeah, I'm not really going to use that, actually. Okay, and in signal. In signal. That's going to the amplifier. Okay. Okie dokie. Alright, so here... Isn't that so much better, by the way? This is a complicated circuit. Isn't this just so much better? The way it's laid out right now. It just makes life so much easier. Because look at the lines that are going between. You got 1, 2, 3, 4 lines, 5 lines if you count this one. You know, you've got 1, 2 lines over here. You got 1, 2, 3, 4 lines over here. So these chunks have almost the minimum needed to get you what you need. Like, imagine if each of these chunks of components was like a different room of your house. Like, if you want to go get the sliced bread and the peanut butter, you don't want to go to different rooms, right? So all you're doing is just arranging and organizing things by doing this. Now, I'm going to assume that I'm going to need to move everything the opposite side of the circuit board. So I'm just going to flip it all. Everything's getting flipped right now. You're flipped. You flip. You flip. You flip. You flip. You flip. You flip. I mean, I could drag and grab these and I don't know. I just don't feel like it. I do what I want. Okay. All right, let's get logical here, okay? I flip you too. I'll unflip them if I feel like it. Backside, front side, doesn't matter to me at this point. Okay, so I've got... What are you? What is your purpose? C10. Okay, so you are from the switch. Okay? And you're going to go to the mute button, right? And you're going to go to ground. So let's just accommodate that. Boom. Done. That's going to be the easiest one. You. Ah, no, I didn't want to connect. You. Aha, you were a jumper. All right. Okay, so ground ref. I want you there. Good. Because I'm probably going to put all this voltage stuff. Like, I'm probably going to have this 12 volts in down here. And then all of this dual rail power supply in the middle. And because it kind of flows nicely, right? This stuff right here actually is probably going to go like right there. Yeah, that makes more sense. So I think the way it's going to go is it's going to move around in a motion, right? So input 12 volts. 12 volts and 5 volts goes to the dual power supply. Dual power supply goes to the linear amplifier, or the audio amplifier. Audio amplifier has a sort of vestigial cousin here. Not vestigial, that's a terrible word. It's got its little cousin here. These switches don't actually have to talk to anything and interact with anyone except for the amplifier. So it's just a little offshoot. And then the amplifier takes it all out the other side. So should be easy peasy. Do I flip you? I don't know. I flip you all. Everyone's getting flipped today. No exceptions. No flipping exceptions. You, what do you want? R7? Flip it. My cats are completely going insane. I'm just going to go up there and there's going to be a cat-shaped hole in the wall. Yeah, funny story how I got those cats. I just found them. I found the first cat I got named Blue, and my wife saw him on the side of the road as I was driving to the apartment. We were living in an apartment for a little while. Now, the reason why you want to live in an apartment is because you're just so sick of maintaining your own home. You just decide to live it up for a little bit and just pay some extra money. I was renting my house out, so I was like, you know what? I'm tired of this. I'm tired of the constant maintenance. I'm tired of seeing the place. I've been working on the place for years, like 5 years, just pouring tons of work into it. No, I'm done now. I'm done. Okay, so you want to go up to pin 14, huh? Ooh. All right. I mean, I could put you down the middle. I don't like that, but I can do that. In fact, I will do that for now. For now, I'm not super happy with that. All right, this is just okay. So this is just a VSW to ground. You can just go around the other side of the circuit board. You. Wow, okay. Yeah, you're a big boy. Don't think I can get away with that. Don't think I can. Although, let me think. I'm gonna try and see if I can finagle this, but I don't have a lot of confidence that I can. Also, I feel a little weird putting. Yeah, you know, I'm just gonna. I don't know if I can get a trace between these holes though. That's the thing. Yeah. Not liking it super much, but I mean it's an amplifier. I don't want to just stick a bunch of stuff. I don't know. I'm gonna put on the bottom side between that rail, just see if I can get away with that. All right, here's another bypass capacitor. Not a big deal. Just put it right there next to the pin. What is this? Another bypass? Okay. Maybe we can make some business happen here. All right, it's business time. This is gonna be quite the row. Now I think this is big enough. The space between these 1206 capacitors is big enough that I can get a via in the middle. I don't know if that's going to negatively affect the signal strength, or sorry, the noise coupling, right? And when you don't know, you're a little more cautious. Okay, that's the bypass for the VSW. What are you? Oh, that's right. You guys are the bypass for down here. So you're going to go to negatives at pin 2 on this thing. Okay, which is right over here. So pin 2 is right there. So the resistor is going to go to pin 2. I've got a lot of space here on the side. I'm gonna make use of that. How about that? How about that? How about them apples? It's pretty good. I like that. It's right near the ground reference. Okay. So the schematic called for 22 microfarad capacitors, a capacitor there, but I just put two 10 microfarad capacitors. At the worst case scenarios, I gotta order another 22 microfarad that's at 1206 package. I think it'll be okay. Yeah, I don't want to. For the in signal, I don't really want to be too far away. Wait, so pin 15 is minus VSW? Oh, I guess it is. Okay. Alright, let's just grab plus VSW there. Now, plus VSW's got a couple of bypass caps there, right? Where are those? Where's plus VSW's bypass cap? Oh, there it is. Well, oh, that's right. There's two plus VSW pins on this thing. Okay. All right. In that case, I can get away with putting the test point right there. Oh, these guys are lined up right. Yep. So I'm using the crosshair strategically to make sure things are lined up. Ugh, this test point is so useless, but you never know. I might want to like do something with that signal. It just feels weird like orphaning a signal on the board. So I put a test point to it just in case I want to do something with it later. Kind of a cop-out, but you know what? That's how I roll. I cop out a lot. I make decisions only when I have to. I'm indecisive. Always. Okay. Now, what I don't like is... Oh, you know what? All right, yeah. Okay, so raw signal goes to C7. All right, so it's not going too far. That's good. And C7... it doesn't hurt anything by being there. It'll be fine. Where's it trying to go, though? So there's in signal right... Okay, yeah, so there's the in signal right there. Yeah, okay. Don't like that. I don't like that. Okay, I need to move this test point over the side. I want this capacitor to be close to the chip, and I want the audio input to be close to this capacitor. You know what I mean? Because I don't want to have a lot of trace. I don't want to have a lot of trace. I don't want to have a lot of trace. I don't want to have a lot of trace. I don't want to have a lot of trace. I don't want to have a lot of trace. I don't want to have a lot of trace. I don't want to have a lot of trace. I don't want to have a lot of trace. I don't want to have a lot of trace. I don't want to have a lot of trace. I don't want to have a lot of trace. I don't want to have a lot of trace. I don't want to have a lot of trace. I don't want to have a lot of trace. I don't want to have a lot of trace. I don't want to have a lot of trace. I don't want to have a lot of trace. I don't want to have a lot of trace. I don't want to have a lot of trace. I don't want to have a lot of trace. I don't want to have a lot of trace. I don't want to have a lot of trace. I don't want to have a lot of trace. I don't want to have a lot of trace. I don't want to have a lot of trace. I don't want to have a lot of trace. I don't want to have a lot of trace. I don't want to have a lot of trace. I don't want to have a lot of trace. I don't want to have a lot of trace. I don't want to have a lot of trace. I don't want to have a lot of trace. I don't want to have a lot of trace. I don't want to have a lot of So an input signal that's like in the millivolt range, the longer it has to travel, the worse it's going to be in terms of signal integrity. It's going to degrade rather rapidly. So what I'm going to do is this doesn't have to face any... Oh, whoops. This doesn't have to face any particular direction, right? So what I'm going to do is I'm going to take this, move it, all of it, and make it so this raw signal right there. There we go. Look at that. Okay, so now things are looking a little bit different, but it's going to be okay. Now, I have no regard to the silk screen right now. That's just really not my concern. I will make that look good later. Okay, so here's plus VSW. Now, plus VSW is here. Oh, man. Okay. I want these capacitors to be as close to the chip as possible, right? So here's plus VSW. See that little line at the bottom? That's kind of where I want to be. Kind of want to be like right there. And I want to put the other capacitor next to it. It's going to be a little bit of a puzzle because something's going to have to give. It's not going to be a perfect solution. It's going to be an optimized solution, right? Oops. Sure. Okay, I want to swing this guy around. Now, I know that the capacitors are in the way of the audio connector right now. It's not a big deal, though. That's going to change in a minute. I'm going to move it. I'm probably going to go ahead and rotate it, to be honest. Oh, where is audio even written? Why don't I see it? Yeah, see, it keeps grabbing that. Stop it. I want to grab the pin. Dadgummit. All right, I mean, I don't care where the audio comes in, right? It can come in from over here. I don't care. So you're going to have some fat capacitors. All right, so you're going to have your connector coming in the top, some fat capacitors, then your buttons on the side. That's just going to be the way it's going to be. It's going to be okay. Actually, I can probably move these buttons. Ooh, you know what? I think I can do that. So that way you have your audio input and your buttons on the same side of the board. That just makes their life a lot easier. There we go. And because the, was it TDA 7293? I forget the part number. Because this chip is, because this chip is sideways like this, I can just bring in the power rails from here. It's not a big deal. So everything's going all right. All right, an out signal is going to come from over here. Oof. How do I want to do that? How do I want to do that? I can just put it like right here so it just straddles the fat caps. I don't want to run the signal underneath the caps though. That's next to it is bad enough. All right, let's just put that there. I think it's gonna have to be good enough, right? Now I know that there's circuit board layout guidance. I'm kind of ignoring it at the moment for both of these chips. So if I go to my data sheets here, I've got layout advice in this guy here, and I got layout advice. Where is it? I think that'd been the first thing I saved. There it is. Okay. I believe there's layout advice in here as well. Oh, the layout advice is for, okay. The layout advice is for totally different circuits. It'll be fine. It'll be fine. I'm not running signals over top of each other too much. I think it'll be okay. All right, so let's see how we're feeling about this. I know it looks like a huge mess right now. It'll look better, trust me. Trust me. I'm a professional. Okay. Okay. I'm ignoring any of these nets that are labeled as ground reference. I really don't care about those. Yeah, how about that? Actually, yeah. Yes. Put that there. That was minus VSW. Okay, and then plus VSW. I'm going to move right there. Looks like these test points are really what's jamming me up. This guy's going to go right over here. He's the most useless test point. I just keep dunking on this test point, but it's just... It's going to be a matter of juice versus squeeze in terms of its utility. It's just not necessary. Now, this is going to look a lot neater once I've only isolated a few of the layers. Right? You're gonna when you show the 3D drawing, it's going to look like there's not a lot here on the top side, and you'd be right. As a matter of fact, yeah, let's go ahead and tighten this up. It's looking pretty loose. I don't like it. I don't want it. Yeah, let's do that. Okay. What's your function? Oh, that's right. You're C7. You're the raw signal to decoupler. So when you run an analog signal, an AC signal through a capacitor, you're going to filter out all the AC component. Sorry, filter out all the DC component. It's late over here. You're going to filter out all the DC component, and you're just going to be left with the AC component, right? So in other words, you're going to remove... If you got a signal that's up here and ground is right here, you're going to take that signal and just drop it down to here. So only what's called the AC component of the signal will be left. It's a good thing. All right. You know, I could move the switches down and everything, but I think it'd be more prudent to just move the rest of this up. Grab you. Just take that and, oh. Okay. And then you, and you, and you, and you, and you. Yeah, let's just do that. Drag all this up. I'm sure it'll be very mad at me soon for what I'm doing to this circuit. Okay. I'm a little iffy about this stuff on the back side here underneath. But we'll just see how that goes. Alright, that's enough. I'm done looking at that. Oh. I could probably move it. Dang it. I could probably move this audio out over here, to be honest. Yeah, I think I can. I want to move these switch over to the left. I would move the switch number 2 over here to the right, but it looks like the standby, the decoupling capacitor on standby is kind of in the way. There we go. I'm giving this a little bit more room to breathe. In signal is also going to get some more room to breathe. I could probably move the power ground. I'm just going to leave you. I mean, you can go anywhere, to be honest. Like, I'm going to put you right here. How about that? Now, I've got a test point for out as well, right? I think. So where's that? Is that TP8? Yes, it is. Okay. This test point is kind of massive and huge. It's probably unnecessarily huge. I could probably just fit it right here. I don't know. Ugly. But, you know, what are you going to do? Okay. Yeah, you're a little more to the left. How'd that happen? Like, went way over to the left. I'm trying to line these up so they're pretty. Pretty tends to work better for some reason. Just when things look good, it just works better. Like an airplane, it flies better when it looks good. That's just the way it goes. If you could just look at an airplane and be like, oh, that's going to fly really good. Okay. All right. So the question is, what do I want to suck over to the back side of this? I don't want to take any of this flyback stuff or this feedback stuff. I don't want to put it in the backside. All right, so R10. Whoops. All right, so that feeds back from pin 2 to pin 7. Okay, so it goes from pin 2 to D1 to R10 to D7 to pin 7. So here's pin 2 to D1 and R10. To pin 7. So it should be like right there almost. Then this guy right here, R8. I don't know what you are. R8 is irrelevant. Absolutely irrelevant. Okay, so R8, I'm going to take you and move you towards the linear regulator because that's kind of what you are. Just get you out of the way. All right. Of utmost importance is R11 and L1 now. So here's L1. Oh, stop it. I hate it when you like grab something that I've already put down. It makes me go like I'm having a hairball. I just make weird noises. Don't worry about it. Everything's fine. Everything's great. Okay. Kind of makes me want to do this, to be honest. Yeah, like this. This one might be a good candidate for flipping, actually. I gotta think about that. Just gonna put it over top of pin 7 for the moment. Okay. R11 is just gonna go to ground from there, so you're not that important. Just gonna put you like that. Okay. R9 and come on. R9, you go with C14. You guys are besties, and you're also very simple, so I'm gonna not worry about you too much. Now, if I take this and okay, so I still have some. All right, so I still have some room for. I still have some room for vias. I think I can make that work. So I might take both of these guys and flip them, actually. Let's see how that looks. Let's see how that looks. Oops, I rotated. Didn't mean that. I want to do that. Okay. Now this is me running a component underneath of an inductor, which I'm not super keen on, especially if it's a switching inductor. Let's take a look at the data sheet. Now, is there a layout? Layout considerations. All right. Okay, so here's a sample layout. Whoa, why is it? Oh no, stop. Stupid mouse wheel thing. Okay. Oh, look at this. Oh, hello. All right. I might just go ahead and do that. Exactly. All right. So here's what we got. Okay, cool. I like this a lot. I like that a lot. So here's L1 and D1. All right, let's just do what the datasheet says. Someone else already did all the thinking, testing, and blood, sweat, tears. Let's use that. Let's use those blood, sweat. Never let good blood, sweat, and tears go to waste. All right, make those tears Make those tears work for you. Okay, cool. D1 is going to go roughly on top of it. Whoop, whoop. I love it. I love it. Okie dokie. Our feedback. Okay, so both the resistors are down here now. So instead of being flipped on the backside, they're just down here. Okay, and the VSW net is facing outward. You're going to be over here. Okay, so that's... This guy right here is actually going to be there. So you see the ground is right here. This ground pin right here, pin 2, is going to go to a via to ground, and this VS is going to snake its way around over to here. Easy peasy. All right, we've got the RC circuit is right there. So all right, so first the resistor on the outside. Now I'm going to make this I might make this a little bit tighter. All right, so the scale is not going to exactly match. It's going to be pretty close though. Okay. All right, just like that. Love it. Okay, let's move some of this crap out of the way, because there's there a bunch of crap I put over here. Let's grab all you guys. Let's grab all you guys. Okay. I don't even know what C16 is for. What are you for? Okay, you're for the VREF. All right. And you are going to pin 13. Yes. Pin 13, yes. Okay. So here's the CV ref. That's the bypass capacitor for CV ref. And that's just going to go, okay, and that's just going to go off to, so CV ref and CV reg are going to be best friends here. All right. That's another one of the feedback resistors. I'm just going to move that out of the way. I don't remember if this 12K has anything to do with anything. I forget. I'll have to just move these around later. Okay. I got to go back and forth between my schematic, the data sheet, and this. What was that? No, okay. R1, you shouldn't even be here. What the heck? You're drunk, R1. Yeah, you need to be far away. Over the hills and far away, in fact. All right, whoop, whoop, flip. Okay. That worked out okay. Cool. All right. I might have missed stuff, okay? Give me a break. All right, so C19, you are the other comparator. Okay, so comp 2, you're going to be down here. I believe R12, you're also the same deal. Are you? Yes. Okay, so there's R12, he's also comp 2. So you are going to go like right there. Yeah, Over the Hills and Far Away is actually apparently some sort of British colonial song. I guess it's about going to war. What isn't about going to war back then, right? C18, you were the VREG bypass. Okay, so you were the friend of this guy. Cool. Too easy. Now, R13, you're a feedback resistor of some sort. Either so there's R13. Okay, so R13, C16. Yeah, C16. Is that right? So C16 goes to F feedback. So there's VREG and There's VReg, and what was the other one I just did? Let me check the data sheet again. CVref. Oh, there's VRef. Okay. Right? Is that right? So CVref is not directly in there. Let me take a look at something here. Did I make a mistake with the schematic? That's entirely possible. It looks like it, yeah. VRef is supposed to go directly to ground via CVref. And then FB2 goes to feedback 2. Okay, so I made a mistake on the schematic. Let me fix that. So VRef, which is pin 14 here, right? I'm not crazy. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, it just goes directly to ground. Okay, so I made a mistake here. So this this R13 should actually be going from VRef to FB2. So really this okay. I'm just gonna go ahead and update the net list then, because that is not right. You can just disconnect from that entirely. Okay. There we go. Now that's directly connected. I'm going to go ahead and regenerate the netlist. Okay. So mistakes are going to happen all the time. You're going to make a lot of mistakes. I'm going to double check this too. Probably off camera. Just double check this. What you want to do is you want to catch your mistakes when you make them, right? You're always going to make mistakes. You need to catch your mistakes. So I'm going to go ahead and update PCB from schematic. You're going to see that C16 or... Let me see. So what should happen is that VRef pin 14. So I have pin 13 going to ground. What is that? I'm just checking things out before I hit the update button. So I had pin 13 going. Okay, all right. So it's just going to move it from. All right. Let's do it. Please. There we go. Now pin 14 is going directly to ground. All right, is going. Pin 14 is bypassing ground via a 1 micro. I think it was 1 microfarad capacitor. Yes. And now R13 and 14 are bridged with this resistor, and that looks like this. Okay, so now I'm gonna drop him low, and I'm gonna drop the other guy low. Just drop him low. There's R14. Okay, and then he's negative VSW. All right, very good. Very good. Okie dokie. I like it. We're getting a lot done. Now, this 0 ohm jumper is going on the back side of the circuit board. His job is to connect ground planes. That's all this guy's job is for. And it's all his job shall be. So yeah, why not right here? So there's ground and signal ground. Perfect. Perfect. Is there a drill layer on here? I like to verify there's actual drill holes there. Whatever, doesn't matter. Okay, cool. So I've done the C-reg and the V-reg and the the V-ref, reg and ref. All right, so now C in 1. And who is that, right? Let me make sure that that is who I think it is. CN1. Wow, okay. So you're the input to PVN. Okay. Weird. All right, all right. And so the whole L and D is all the way up here. Okay. Good lord. Weird. Okay. So we're actually going to go underneath this fella. So I need to find C in. Here's the C out. Or here's the C outs. They go from the audio ground, the audio signal ground, to the voltage rails. Got those confused. Got those mixed up. There we go. Okay. So C in. Here you are. All right. Feeling it. Loving it. Next, L. So the ground side of L is going to go into the middle here. Whereas this other guy. Yes, just making sure it's connecting to that pin, that's all. Oops. Trying to grab you. Okay. What are we doing the D? Okay, the D is, okay, the D2 is actually on the side here. Alright. Works for me, Mr. D. Keep your mind out of the gutter. My mind is always there. There's not enough room for both of us in that gutter, okay? R8, what are you? What are you in for, R8? Oh, you're the, yeah, okay. I don't care about you. Oh, holy moly. What a day. What a day. Yeah, there's no reason not to connect the, to bridge these two guys at the chip. To bridge the, both grounds at this chip. There's no reason not to do it. Okay. Alright, let's just make this shape right. Okay, so there's C out. So I'm just going to grab both these guys and just slam them right next to each other. Close enough. And the grounds are all over the place. That's kind of to be expected. What is 1, 2, 3, 4? What is pin 4? 1, 2, 3. Oh, that's ground. Okay. I'm a little curious then on what this enable signal is. So it's pin 9 and pin 11. Okay. I might as well just toss this on the backside of the circuit board as well. Just isn't. Oh, wait. Oh, never mind. Never mind. Alright, there's some room for me to go between these. Okay. I can make this happen. I can make this work. Just move you there. Whoopsie doodle. Move you here. Close enough for now. And you move you here. I love it. Okay. Oh. Get a good big old relaxy chair. Okay. Alright, and the 7805 is the easiest circuit in the world. This is going to be kind of a long circuit board. Ooh, you know what? Put you right here. Love that. That's great. Well, where does it expect V in to be coming in from? It's expected to be coming in from the other side. Okay, okay. Yeah, because C in is right there. Let's do it. Let's do it this way. Sure. Of course, I leave something behind. Let's put you in from this side. All right, there we go. Now we've really shrunken the board down just now. We made it a little bit more stout and not quite as long. That should serve us well. I'm gonna go ahead and put the 12 volt test point right there. Ooh, you know what? I'm feeling spicy. So the ground plane's on the back. That's a given. Easy. That's easy. Okay. The 5 volt is going to need a via to get up to the enable signals, which is fine. That's totally fine. And the 12 volt can actually jump in, go to the back plane via the terminal block here, go to this chip, and then come back up through this test point here. So that's going to work out really well. I don't care. Just, ugh. Get out of my face, bro. Ooh. I don't want to interrupt the ground planes too much, although this is a ground plane. So I can shove that like right in there. This is a linear regulator, so it's not going to make a lot of noise. Don't think it makes any noise, actually. It's kind of the point. Alright, so I got my 12 volt there. Okay, I got my 5 volt here. I probably should have thrown a couple of LEDs on this thing for good measure, but whatever. I'll just use a voltmeter to know the thing is on. I mean, LEDs are cool and all, but there really isn't any point. Oh, cool. Alright, so I can actually jump through and use the test point for the plus 5 volt as a via as well. That makes life a little easier. Man, okay. Let's bring you in this way. Okay. Let's bring you over here, because that's unused territory. Signal ground, yeah. You can go wherever you want, I don't care. Actually, signal ground can just go right next to this plus 5 volts. You and you. Could just move a little bit to the left. I love it. I freaking love it. You know what's also cool is I think let's see if this breaks my setup. I think I can actually just go to view and do 3D view and get kind of an idea of what this thing's gonna look like. Oh, I left it on super fancy pants render mode. I do not need that. All right. Oh, it's going to look roughly like that. If I can bring this stuff up or tuck it in the back, that would be much better. So I can make some use of that. Told you it would look really barren. Like, it looks really busy on the board, but it's really barren, actually. It's not the best used circuit board, but this is a prototype board. I'm not really going to put a ton of effort into optimizing it, although I could. I totally could. Maybe I should. You can argue that. I can see an argument for that, but I'm just not gonna. So there. Can't tell me what to do. You're not my dad. If you are my dad, then I'll see you at Thanksgiving. Dad. I don't even know, man. I don't even know. Let's do another 3D view. See what we're looking at. That's not terrible. It's kind of what it's recommended to be, and I can put my title block over here, so it's not the most wasted space. And I'm a little leery about just throwing stuff on the back side of the board, and opposing the recommendations from the manufacturer. To be perfectly honest, here's my test point layout. By the way, it's a hot mess. Let me see what time I've got on this thing. I've been going for an hour and 10 minutes. I'm going to go ahead and break this thing up, and we're going to finish up the layout. It looks like we're doing pretty good so far. Like, this is not the worst. So what we're going to do next is we're going to clean up all this silk screen. In order, what we're going to do is we're going to make the connections between everything. We're going to pour our copper planes, our copper pores, We are then going to run our DRC check to make sure we didn't violate any rules. Pending a successful DRC check, I'm going to rearrange all the silk screens and add the artwork needed to make this thing not look like crap. Because you can't print a W on top of a hole. I've tried printing W's on top of holes. It's been my lifelong ambition. Never works out. Never works out. So I'm going to rearrange these things. I don't know what I'm going to do under here. This is going to be a mess. But, I mean, if we don't get any DRC errors, then I'll consider that like a small miracle. All right, guys. I will clickety-click, clickety-clackety, be right backety. I will see you guys next time and enjoy some more therapeutic building, chalking, chatting, and ad hominems. And just me grouching and griping. Hey, it's fun, okay? It's fun for me, at least. Hope you guys enjoyed it, and thanks for sticking around to the end, and I will see you guys next time when we clean this hot mess up and order it.